Hello, everyone. Thank you for joining me for my talk about Java microservices and Kubernetes, and the little surprise that you see under the back. Some of you might have seen it, the ones that were early. I will try to fight your food coma, so I hopefully succeed. So I have a couple of live coding and some exciting demos to show. All right, but first of all, to all the women that are here in the room, happy Women's Day, International Women's Day. Are there any? Yeah, I see a couple. Good. Okay, about myself, I'm a developer advocate for the Google Cloud Platform. Very important, the developer in there. So we talk primarily to developers, mostly about, like, on the one hand, raising the awareness that Google Cloud Platform is out there as well. Not only Amazon, AWS, and Azure is out there, we are existing as well, growing rapidly. So on the one hand, raising awareness, but most importantly, and that's like the advocate and the developer in my title, is to talk to you guys as like a feedback loop to our engineering team. So I'm reporting also into engineering at Google. I'm not marketing and I'm not sales. And so we want to hear from you how you use Google Cloud Platform, what you like, what you don't like, how we can improve things like that. So to do this, you find me at Twitter or on GitHub, or also under the same name, hossyrossi@gmail.com. You find me as well. You saw it already up there as one of the keywords. If I'm not talking about tech and traveling around, I like to take pictures. So this is one of the pictures that I took in the desert of Mauritania. I did a rally 2 years ago, which was basically 7,500 kilometers from Dresden, my hometown, to Banjul in Gambia. And that was the start of the desert section of that rally. For 2 days, no civilization, no internet, no clouds, only on the sky. All right. I also want to give some tribute. So a lot of this content for this talk is from my colleague Ray Thang. So you find also some recordings of him at JFocus and JFall and DevOps about a similar topic around this. Okay. So first of all, who of you has heard about Google Cloud Platform? Awesome. So I can stop here and give you some free time. That's awesome. Usually not that many hands come up. Who has done something? Who has played with Google Cloud Platform? Okay, Amazon Web Services? A lot more. Okay, so hopefully we change that with some exciting demos at the end of the talk. So microservices. Probably a lot of you think like, oh no, not again. So I want to stop here at that slide with microservices. I'm not going to talk about the theories and like when it's good to use microservices, when it's bad. What I want to show is like how easy it is nowadays with the frameworks that are existing to develop microservices. So we will dive into some live coding in a minute. Before I do that, I want to just like put a frame around the idea in terms of just imagine to have a guestbook application, and you have different components or microservices that create or like work in this guestbook. So we can think of something like this. We have MongoDB as a backend for our persistent storage. We have a Redis as a cache because we assume a lot of visitors for our guestbook, and not that many that write actually something in the guestbook, but a lot look at this guestbook. And then we have our Spring Java running, which is basically talking to the cache and the MongoDB, and provides a REST interface for our AngularJS front-end app. Now, we want to be able to manage this like flexibly and also scale that flexibly. So that's like I showed that here with the Nginx and the Spring Java, that it's independently, this can be scaled. So usually like at the front-end layer, you reach your capacity first and you can scale out. All right, so let's dive into some live coding here. So I hope everybody, can you see that in the back roughly, or should I make it a little bigger? Maybe like this. All right, so there are many frameworks out there to like build web services, right? And one of the ones that I like to use is Spring Boot. And so let's start with hello world Groovy file. And let's show how easy it is actually to build like a very simple web service. So in this case, I want to have my hello world web service, which does a very simple multiplication of two input values. So let's see int y. And then we just return in the result, we want to return all the input parameters, so x and y, and of course the result, the multiplication, so x times y. All right, so far it's still not a web service, so Spring Boot, to make out of this very simple class here a web service, so we use annotation. So let's use REST controller here, which tells Spring this is REST controller. And then I have to do some path mapping. So let's do path mapping here. And I want to have that the input parameters are just part of the path. Very simple. Okay. And then, of course, I have to also, in my function, annotate where these path variables go. All right. Not a fast typer. Do you spot any mistakes? Does it look about right? Any Spring Boot experts in the room? All right, let's give it a try. So very easy. If you install the Spring Boot CLI, what you do is basically Spring Boot run, and we have an error. Let's see. What does it not like? What did the error say? Okay. Oh, the path mapping is wrong. All right, let's cheat. And oh, what's happening? Okay. Should be right. Is anybody spotting the mistake? Let's see. Oh, yes! Thank you very much. Awesome. These blackout moments. Okay. Thank you very much. That gives the t-shirt at the end. All right. Let's see if that works. Okay, perfect. Thank you very much. All right, so how does that look like? So basically, we have our multiplication here, and I can do this a little bigger here as well. So basically, what day is it today? It's March 8th, I think, so that you can see that it's not a cached result. Okay, works good. Okay, so basically, that's how easy it is nowadays to build a simple web service, right? So what do you do from here? So like the traditional way of deploying this is basically you build a jar and then you give it to your operations team and they procure some resources basically, and that can take up to like many months to build the, to like plan this and procure all the resources and then deploy the jars. So there's a big change nowadays how you do that. So mostly coming in with the Docker movement. So how many of you have played with Docker? And many of you probably went to the Docker talk. So nowadays you can actually, I mean, also one of the problems that comes in with like handing these jars over to a different team is always you have different configuration, right? So I have seen it a lot that you deploy or you develop something in your development team, you ship it to testing, everything fails. You ship it to prod, everything fails because some configuration don't match up or some libraries that you have installed on your machines are different to the ones that you use in your development environment. So with Docker, awesome. With Docker, you basically bundle everything, all of this together. And how would the Docker file look like for this? So there, my colleague developed a Docker image, and you see here that you basically see nothing in this Docker image. The reason for that is this is using the onbuild function in Docker. And what that means is basically that if you look at this Groovy onbuild Docker file, what it does is it's setting some environment variables where your source is, the Groovy version, Spring Boot version, and it installs all the Spring tools basically into this Docker container, and then it's running your building your jar file and running your jar file. And building the jar file is exactly what this onbuild statement is doing down here. So basically, it's loading your source code into this Docker container while you're building it, and then creating this jar file. And when you run this Docker container, you basically run this jar file what you build in this container. This onbuild function is only executed if you derive from this container. All right. Okay, so once you have these web services, which you need for your guestbook application or for any other application, you run into a lot of questions like, where do you deploy it, how do you deploy it, how do you scale it, what resources can you use, how do you do port mapping, things like that, right? So we went through the containers on this example. So there are like things like, okay, once you have all this figured out, where to run your microservice, there also come things in like, how do you keep them healthy? Like, how do you watch that these microservices are healthy? If they are not healthy, that they're restarted or rescheduled on different resources, things like that. So with part of these challenges that you see here, Docker Compose can, of course, help. So Docker Compose, you basically define your landscape, how it looks like, you run Docker Compose, and it sets up this landscape. What Docker Compose doesn't help you with is monitoring that state afterwards, right? Monitoring, is it still in that state? How do you keep it in that state? And that where is cluster management comes in Kubernetes. So as a teaser before that, if you look at Google, everything at Google runs in containers. Be it Gmail, be it web search, be it Maps, be it Google Drive, be it the Android Play Store, everything runs in containers at Google. All kinds of workloads as well. It's not only the web surfing workloads, it's also our backend workloads that run in batches over days or weeks or things like that, right? So very diverse workloads there, and if you look at how many containers get scheduled every week, it's over 2 billion. This number is actually like roughly a year old already, so I believe it's quite a bit more nowadays. All right, so if you look in, this is a data center in Council Bluffs in Iowa. So if you look at this, it's like a couple thousand machines. And of course, your developer doesn't go there and logs into one machine and deploys his app there, right? What you want to do is you don't want to see that as like individual resources. You want to manage this as one. The developer shouldn't even care about where my stuff is running and how it's running. The developer should concentrate on developing and innovating, right? So you want to take this work away from him. At Google, we have a system called Borg, and there's also a paper out there. If you Google or Bing or Yahoo the Borg paper, you will find it. It's a very interesting read. I encourage everybody to read it. This system, how do we do that internally? How do we manage these resources? So let's look at a job, how you would deploy an app within Google. You basically have a job description, let's call it Hello World. You say like what cell it's running in. So one cell is roughly 10,000 machines, so in the medium. You give it a binary that you want to run. You do port mappings. You describe requirements in terms of main memory, CPU, disk. And then at the end, you basically say, I want to have 5 instances running of this binary. And if you Google scale, you do sometimes 10,000. So how would that look like in terms of ramping up 10,000 instances, right? So you see here a graph in terms of like how long it does take to ramp up 10,000 instances, and it's roughly 2.5 minutes. The reason is we don't want to overload our networks, our storage systems, and everything like that. So we do like on purpose a slightly slower ramp up with what we could probably do. We could probably be ramping up 10,000 instances faster than that, but we don't want to because we don't want to stress our infrastructure that much. So if we look at the system, it's basically we have a Borg master and we have our binary that you build. There's also an open source version of our build system out there called Blaze. Distributed build system, so you build your binary, you push your binary to a storage, and then you push a configuration file to your Borg master. The configuration file that we just saw, which basically describing the requirement restriction and things like that. Now, there's a scheduler which like periodically asks the Borg master, hey, what is the desired state? What's like the current like desired state for jobs that we have? And then also asking what's the current situation in terms of how many do we have deployed? So once it knows that, it gives the Borg master an instruction in terms of where to schedule that workload. The Borg master goes out to its workers, the Borglets, and tells them, hey, please run this binary for me. Now the Borglets go to the storage, grab the binary, and run the hello world, and then it looks like this, right? Okay, so this is like the system, how it's working within Google, and we took all these experience that we gained running and building the system and open sourced it. We didn't like one-to-one open source our internal system because it developed over many years and there's certain technical depth that you build up. So we really said like, okay, we want to do a fresh start if we open source the ideas behind this. And we, from scratch, developed a system called Kubernetes and open sourced it. So it's written in Go. Everybody loves Go now, so we wrote in Go. It supports different runtimes, so you can run it on cloud or bare metal. So we have a managed service as Google Container Engine where you can play with it, but you can also install it on a VM or virtual box on your laptop if you want to play with it. The default container system that Kubernetes supports is Docker, but it can also support any other kind of container format. And if you look at the open source project at GitHub, it has over 10,000 stars, but like I think it's more than 13,000 stars by now. So it's one of the very, very active projects on GitHub, and many forks as well, and commits, like 26,000 commits. The Google is not the biggest contributor. It's still the biggest contributor, but like if you take all the other companies together that contribute to Kubernetes, they are like a bigger contributor than Google by now. And you see a lot of very big names on here that contribute to Kubernetes. So it's not an only Google project anymore, by far not. All right, so how does it look with how does it look like at Kubernetes if you run your job basically with Kubernetes or your containers? It's pretty similar in terms of binary. In this case, is your container, your Docker container that you build. Basically, you push it to a registry that can be Docker Hub or that can be your private registry. With Google Container Engine, we offer a private registry that you can push Docker containers to and use that within Kubernetes. And then, of course, we also have a configuration file which we send through the API, and Kubernetes also, again, looks at what is the desired state and what's the actual state and makes sure that this desired state is reached. Again, we have the worker nodes. In this case, we call them kubelets that get the workload to say, like, hey, please run this Docker container. It will go to the registry, pull the container, and then run it. So in Kubernetes, how does it look like a configuration file in Kubernetes? It's basically you define, in this case, a service where you, again, you define the resource limits that your container should get. In this case, we have a memory limit of 128 megabytes. and then a CPU of 0.1 of your CPU that's available. And then you define the ports that you want to map, your container ports and the protocols. And then again, you can also define like how many replicas you want to run, be it 1 or again, be it 10,000. Okay, so there are 4 main concepts in Kubernetes that you work with. So I will slowly, or like I will go briefly through these concepts and then show a demo and explain them a little bit more in like during the demo. So the 4 main concepts are pods, replication controllers, servers, and labels. Pods is basically a grouping of your Docker container. The pods always travel together. What does that mean? That basically, if pods are getting scheduled, they always get scheduled in one node. So the containers that are running in one pod, they always travel together. They are co-located. But it's very important to know, pods are an ephemeral concept. Which basically means you never talk to pods directly, because they can be rescheduled at any point in time. They're basically, yeah, they can be stopped and put and scheduled on a different node. So replication controllers are there to watch the state of your pods. So with a replication controller, you basically say, I want to have 5 pods of this, 5 of these pods running. And the replication controller makes sure it looks always like how many are running, how many are healthy, start new ones, stops some of them, things like that. Now, to be able to actually access your pods, you use services. Your services give your pods, so to say, a stable IP. They do a basic load balancing. There's a possibility to have different kinds of load balancing with services. But basically, if you talk to your service, you always talk through services. To your pods, you always talk through services. And labels are an orthogonal concept on top of all these other concepts. On any kind of API object, you can attach labels. And what that helps you is basically, for instance, let's assume you have different versions of a front end running. And you do like an A/B testing, or you do a rolling update while basically people are still working with your application, you're doing a rolling update. So what you do is you select with your service, you select the group of pods. And this group of pods doesn't matter like which version that is. And then the replication controller, they are only responsible for managing version 1 or managing version 2. And while you're ramping down version 1 and ramping up version 2, it's all served by one service. And that's allowed by basically, or that's possible with using labels very nicely. There are other things that you can do with labels. Some of them I will show right now. Okay. So, okay. 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 So what do I show here? So this is basically a visualization that is also available on GitHub. It's open source, so you can, if you want to play with it as well. So what I have now is I have a Kubernetes cluster running on Google Container Engine. And this Kubernetes cluster has 3 nodes. And what I have started here already is basically a front-end service which obtains a public IP address so that I can talk to my services from the outside. But other than that, it's pretty bare what is running right there. So I showed you before my guestbook application, which basically has a MongoDB, Redis, and guestbook backend and a guestbook frontend running. So I have all that is basically done with these YAML files, which give me the configuration. And I want to look into in one right now. Let's go into Mongo, and we have a Mongo controller and a Mongo service, so let's have a look here. So basically, this is a configuration file which describes a replication controller. I give it some metadata. One of this metadata which is important for the visualizer that I just showed you is the visualize true. So basically, this label tells my visualizer to pick up on this replication controller and show it. I will show that in a minute. And then again, I basically say how many instances do I want to have running, which container do I want to have running. So I'm using the standard MongoDB container that is available on Docker Hub. Nothing special. I'm mounting a persistent volume in there. This persistent volume that is mounted in there is basically read-write and can only be mounted into one pod. So when I now would say like I want to have 2 replicas of this running, this wouldn't work with the same persistent disk. So there has to be one only. There are possibilities to mount volumes read-only. In that case, you can mount it into multiple pods. All right. So another thing that I mentioned is this basically will schedule the pods. But I need a way to talk to these pods. And for that, I use a service. So that we have an API object service here, which basically is doing the mapping of the port and then give me a stable IP to talk to my Mongo service. So to run this, I use kubectl, which is, in my mind, the magic wand for Kubernetes. It does pretty much everything. Can I spell today? Let's try this. Okay. So what does this do? Okay, front end already. Oh, that was not smart. Let's do this. Okay, the Mongo service already existed, so I didn't clean up very well. All right, so what we see now is basically, and I started a lot of things like at once right now. So what we see right now is basically I started 4 front-end controllers that are running. I started my Spring Boot guestbook back-end application. I will stop my front-end v2. So I basically have my MongoDB running, I have my Redis master service running, but the container is still not running. So let's have a look at my Redis master. I have my configuration files in here. Controller. Okay. So in a second you will see here, okay. So basically, these concepts we have here, Redis master is my replication controller, which watches my container. And then down here, I have the pods that is running or that is watched, basically. So now we have MongoDB, we have our Redis running, we have our Spring Boot guestbook application backend running. And you see here, it's 5 instances of my version 1. And then I have my front end version 1 running as well. So let's see if the guestbook works. Okay, and then, oh, yeah, okay. Wrong event. So that's what's happened, right? You deploy an old version, and that's Java user script day in Saxony. So what do I do? Okay, so what I want to show here really quick is actually I want to do a rolling update. So I have a second version, and we have a quick look into how that looks like. So, okay. Front end, and all right. So basically, what I'm doing here, I did the change already because I have a slow typer. I did the change already in this file. So I changed my title, I changed the header, basically, and then I also applied a different styling in terms of that I now want to have a light blue background. So let's see if that works. And basically what I'm doing now, I would push, I would basically do a Docker or gcloud Docker push, and of the second version, I have done that already, so I can basically do a rolling update. So let's have a look. All right, how does it look like when I do a rolling update? So again, it's kubectl to do the rolling update. I have my front-end v1, which is my replication controller for my front-end v1. And then I say, like, okay, I want to replace that with my frontend RC v2. But before I do that, I want to check if I have enough enough instances that I want to create with my front v2. So let's see how many replicas I have here. Replicas 1, okay, I have already running 5 of my version 1, but I also want to, let's say, have running 3. Okay, so let's do the rolling update. Okay, and what this period v2 basically says, let's have a look while it's doing it. So you see here like how quick basically a new replication controller got created, and now it's starting version 2. So you see now, okay, it's pulling down the Docker container, so it takes a little while, but now you see already version 2, one instance is running. You saw this update period that I have here in the configuration in my command line statement, which basically says it's starting a new container of the new version, and then it's waiting for 2 seconds after that one is healthy, and then pulling down an old version. The reason for that is basically if anything happens, if anything goes wrong, you just you start seeing a lot of errors in your logs and things like that, you can kill the rolling update and basically stop it and go back to your version 1. So now if I start this and running this, I hope. Oh, welcome to Nginx. Demo effect. That's not nice. Okay, the demo gods are not good with me today. All right, so what you would have seen, should have seen, if I wouldn't have done any mistake, you basically see the new version with jDays and the light blue background. For some reason, something in the middle had a glitch. But what I wanted to also show, which is difficult to see here, because right now my laptop is giving up on me. So I missed to show that, but basically this front-end service that you see here was surfing both versions while it was doing the rolling update. So if it would have worked, you basically would have seen version 1 and version 2 side by side. Like if I would have refreshed a lot of times, I would have seen both versions till the rolling update is done, and then you only see the new rolled out version. Okay, let's give it another try. Not working. Okay. Okay, so one of the next things that I want to show, and I have, I think, 10 minutes left, which should be enough, hopefully, is I brought a little surprise here. And that is this Kubernetes cluster, which is basically Raspberry Pi, 5 Raspberry Pis. And let me go to the slides really quick. So how did that develop? At GFall 2015, my colleague Ray Thang that you saw earlier, that I introduced earlier, he went to JFall and saw a Dutch company called Quintor like showing a Kubernetes cluster. And he was like, that looks a Raspberry Pi cluster. And he's like, are you running Kubernetes on that? And they're like, no, like, we haven't thought about it, but yeah, maybe. So he worked with them together and deployed and brought up a blog post to run Kubernetes on a Raspberry Pi cluster. So this is the company. Arjen Warsnik was the main contributor to that, basically building and helping with the Raspberry Pi cluster. And once we tweeted about it, like one of our main contributors for Kubernetes was tweeting this. I think the Raspberry Pi Kubernetes cluster is the new hello world of cloud computing. So who of you was in a data center and had like the strong urge to pull the plug? Only one? Seriously? Nobody? Okay, so like I've been to the IBM data center in the Silicon Valley, and I had access to it. Like I kind of like had like, what happens if you pull something? Probably nothing good to me. I probably wouldn't have worked much longer there. But you basically want to prepare for the situation that anything goes rogue, right? So this Kubernetes cluster basically has a nice effect in terms of that we can demonstrate what happens if hardware fails or connectivity fails. What do we have here? We have 5 Raspberries, we have an Anchor USB hub, we have a network hub, we have some nice cables. I don't have the nice white cables. I choose the Google colors and black cables. And if you want to build it, if your birthday is coming up or anything, you find the blog post here, and it also links to the material list and how to build it up. What's running on these Raspberry Pi clusters is basically the base OS is Hybrid Linux, which already comes with Docker support to run Docker containers. And then we use Kubernetes on ARM, which is also a GitHub project which installs you etcd, some different version of Docker, Flannel, and then Kubernetes to run it. All right. This was too early, the cat picture, sorry. So let's have a look. I hope it came up because yes, it's right. Okay. So I only have to do one thing because I want to also show you the visualization. I have to switch my context really quick, and then I do a proxy here. And then we should see 5 nodes. Awesome. OK, 5 nodes are running. And you see I didn't clean up again. MySQL is running on it as well again. All right. So before I show the MySQL demo, which hopefully is possible, I want to show you just a very simple Nginx for a starter. So let's go to our master, and then we run an Nginx. So it should show up here, hopefully. Let's see. OK, Nginx here. OK. And now I want to scale that. So cube, skdl, scale, rc, Nginx, and then let's say replicas equals 5. OK. So now you see down here 4 coming up. I don't know where the 5th is, probably missing, hiding somewhere. But you see also that where these Nginxs are running at, right? So basically down here we see the IP addresses of our nodes where these Nginx is running on. So to test that this Nginx actually responds to something, I actually want to give it a service to be able to access it. So let's give it a service. So now we have an Nginx service here that is exposing it, and I expose it on my master. So what I basically can do is, hopefully, works if the demo gods are a little good with me. We should see that. All right, welcome to Nginx. It's working. All right, who of you wants to play real-life Chaos Monkey? Anybody? All right, come out. All right, what's your name?
Andrews.
Andrews. All right, nice to meet you. OK, so we're going to play real-life Chaos Monkey. So we see here the Nginx is running on 14, 12, 15, and 11. So you can choose to pull, but wait, I don't know if it will work, but let's not pull the cable of the top Raspberry Pi, because that's our master, and then everything will break. So choose one of the lower 4, and maybe not the middle one. Yeah, that looks good. Let's see. All right, OK, awesome. We have a pulled network cable, so let's see what happens. So this should be node 14. So now it takes a little while, but we see, OK, it's recognized that the node is missing. And you see down here, OK, 14 is missing. It means this pod is not there anymore, and it schedules a new one, which is now 13. Thank you, Andrew. All right, so that's awesome, right? It's like really quick starting a new one. But now this Nginx is still running on our node 14. So if we plug it back in, we will see that the node is coming up live again. It will realize, OK, now I have suddenly 6, or in this case 5, you only see 5, instances of this Nginx because it's still running. So it will actually stop one. You saw that it will just stop the one that was running on node 14. All right. So I will clean up the area a little bit. So let's delete the Nginx replication controller. And you still see here 3 minutes left, should be fine. You see, oh, our MySQL was running in this node as well. Okay, awesome. Okay, so you see now here that we have a MySQL running on our node 14. Let's see if we can talk to it. So I have a service running for that one. So let's see. All right, not gonna happen like that. Let's do it this way. SQL is u root minus p minus host, and then we do. Okay, so a super secret password, and it might not. Yay! Okay, who remembers SQL? Okay, let's start. We create a database, jDays, okay, and then we use this. Okay, that works. Okay, we select or show tables. Let's do this. Nothing there, right? So we create a table. Let's create table jDays because we like redundant. So and then we say, let's say message varchar 30. Looks about right, hopefully. Show tables. Awesome, we have a table. So now let's insert into jDays a message. No, should be fine. So let's say hello jDays 2016. Let's see if that works or if I missed. Yeah, I have an error. And this. Awesome. Okay, so let's do select from jDays, and it should show it. Okay, we have one thing here. So because I'm a little running out of time, I'm killing it myself right now. So it's running on 14. So if I pull the plug here, it should show and reschedule my MySQL container. What does it mean? Basically, we have a persistent volume claim in this pod. So basically, it has to take away this persistent volume claim and now give it to a different node where we start the MySQL pod. Of course, you shouldn't do this in production, like killing MySQL, like not a good thing. I only pulled the network plug, but still, we shouldn't do it. So let's see if we can talk to it again. Super secret password, of course. So it takes a little while to like update the service that we now have a different. So I have to give that another try. It might still not work. So what can we do is we can actually look into where's this service pointing right now. Pod. So I describe my pod. So basically, it's telling me here it's running on 192.168.0.13, and it has a private IP, which we say up here. So this is the IP of the. So let's do a ping if this is even alive. Oh, it's alive. Okay. So maybe we are lucky now. Secret password. Still not. So let's do a shortcut here and try this. So usually the service updates a little faster, but for demo purposes I do this. So let's see if we have still our database. Seems okay. Let's do a select star from jDays. And still there. So at least this demo worked. Thank you very much for your attention. I hope I could create a little bit of, let's see, presentation. That's basically the cat picture here, a little bit of curiosity. You now know on which side I stand. If you want to know more about Google Container Engine and Kubernetes, you find us on cloud.google.com and also on GitHub in Kubernetes. You find us on Twitter, on Slack, and many other channels. So if you want to learn about it, if you want to have our opinion, if you need help, you find us there. Anybody with a question? No questions? Everybody happy? Food coma? I didn't manage to fight the food coma. All right, one.
Excuse me?
Yeah.
When you're using Kubernetes in production, do you stage the databases and application servers orchestration?
So, so what you would do is basically to deal with different environment in terms of like development environments and staging, testing, and then production, is you would use namespaces. Because with namespaces, basically you can keep your service names and your service endpoints. So Kubernetes has a DNS. So if I deploy, for instance, an engine X service, I can talk to it by like engine X and then port number. To keep that name schema, you basically work with namespaces and deploy your different workloads into different namespaces. And that way you also can separate your database, so to say. But then the thing is also about Kubernetes. Kubernetes is not the first citizen where I would run persistence. I showed it here, but in the end, basically, Kubernetes doesn't support you in a way to scale your persistence. It's not made for that. It's more scaling stateless workloads. So scaling in stateless front end or a stateless like back end to some extent. You have some statefulness that you can manage with it in terms of sticky sessions and things like that. So it gets the one user gets routed to the same pod every time. But your persistence would, in the end, run somewhere else.
Okay, thank you.
Sure. And if anybody wants to, we have some stickers here, and also the Chaos Monkey that came up. I have a T-shirt for you, hopefully the right size. All right, thank you very much.
Thank you.